Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 1, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. First of all, let me explain you a little bit about physics, how you can improve your understanding of physics. If you really wanna improve your understanding of physics, you need to adjust the way you study physics. I have seen many students, they spend a lot of time on physics, but they don't improve with time. They don't have clear understanding of physics. And they stuck with questions again and again, with same type of questions. The reason is that the way they study physics, that is not correct. So the correct way of studying physics is, first of all, derive equations and try to understand the logic behind equations. So this is one suggestion. And then when you do questions by yourself. Try one time, second time, and try to figure out where you are making mistakes. And then look at the mark scheme finally. Don't look at the mark scheme, just looking at the question, then looking at the mark scheme, then solving. This is not good technique. This is not good way of developing understanding of physics. So look at question, try one time. If your answer is not correct, try again and try to figure out where you are making mistakes and keep record of those mistakes or those misconceptions. Physics is all about clear understanding and misconceptions. The way we develop understanding of physics, we try to reduce misconceptions. When you minimize misconceptions in physics, you have clear understanding of physics. So it's very good to do questions, try more than one time, and try to figure out your own misconceptions and make a list of those misconceptions and try to avoid them in future. If you follow these two suggestions, means try to understand the logic behind derivations and do questions by yourself and make a list of misconceptions, you will see a big change and you will start loving physics. Physics is just about logic. And if you wanna think a little bit more about physics concepts are closely related to human behavior. And also if you try to relate them with human behavior, it will give you very clear understanding and it will help you to see the real applications of physics. I hope these points will help you to improve your understanding, and if these things help you to improve your understanding, please leave some comments so I can see how this method is helping you to improve your understanding of physics. Question 14 says a hinge trapdoor is held closed in the horizontal position by a cable. Three forces act on the trapdoor: the weight W of the door, the tension T in the cable, and force H at the hinge. Which list gives the three forces in increasing order of magnitude? This is a typical question. You will see this question in many past papers. So understanding of this one is very important. So first of all, the first step we can do is we can resolve forces into components. So we can resolve into horizontal and vertical component. So this is vertical component of tension and this one is horizontal component of tension. We can repeat the same process for hinge force as well. And this has two components. One is vertical component and one is horizontal component. We can label these components first of all. So we can say this one is Ty and this one is Tx. Then this component is Hx and this Hy, because this is vertical component. So this one is Hx and this one we can label Hy because this is vertical component. So we can say this one is Hy. Now if you look at these forces along vertical, we can simply see Ty should be equal to W plus Hy. So from here we can say W should be equal to Ty minus Hy. So it means Ty is greater than W. So we can say Ty is greater than W. We can also say T is greater than W. So this is the first result we can get from these forces, mean by comparing these forces. Now if you look at given options, so T has to be greater than W, means T has to be on the right side, that this is not on the right side. So this is telling us that T is smaller than W, so this is incorrect. And if you look at this option, this is also telling us that W is greater than T, so this is also incorrect. Now we have two options, C and D. So we need to compare H and W. In order to compare H and W, we can take moment about this point. So this point and this point is about halfway, mean distance from this pivot, for example, to this point, and distance from this pivot to this point is almost same. So what does it mean? So it means moment due to this one will be counterclockwise, moment due to this one will be clockwise about this point, and this point is about halfway. So we can say HY times, we can say this distance, for example, we can label this distance is D1, we can say this distance is D2, so we can say HY times D1, this has to be equal to W times D2. As in this case, D1 is about equal to D2, it means that HY is about equal to W. HY is about equal to W. So how about H now? H has two components. So H has two components, that is HY square plus HX square. So this is H, but W is equal to only vertical component. So from here we can say H is greater than W. So this is the second result you can find by comparing forces. Now if you look at given options, so W has to be the smallest, so we can say W should be smaller than H, H should be smaller than T. So this is the final result. So it means we should have W first, then we should have H, then we should have T. So this should be the order, increasing order, magnitude is increasing in this direction. So C is the best answer. So moment, we can use concept of moment because it's hard to compare the magnitude of forces directly. So we can use the concept of moment. By comparing, we can find out. As this beam is in equilibrium, it means that net moment about any point is equal to 0 and net force in any direction has to be equal to 0. I hope this question makes sense, and if these videos are helping you, please like and subscribe because your encouragement is very important. And if you're looking for more resources, you can also join Patreon. On Patreon, I can help you one-to-one. So based on your needs, based on your level of understanding of physics, I can provide you resources. So that can be a great platform for you to improve your understanding of physics. If you're struggling with physics, give one try on Patreon, join Patreon and see a big change in your understanding of physics. Question 15 says, what is definition of force? Force in physics we define F is equal to delta P over delta T, means rate of change of momentum. So we can also say that this is delta times mv divided by delta T, rate of change of momentum. So mass can change, velocity can change. Now if you look at given options, option A says the product of mass and acceleration. This is telling us F is equal to ma, but this is based on one assumption, means mass is constant. We can only use this one if mass is constant. So this is based on assumption, so this is not definition of force. So option A is incorrect. Option B says the product of mass and velocity. So this is telling us P is equal to mv. This is momentum. So this is also not force. The rate of change of momentum. So this is definition of force. The rate of transfer of energy. This is not force. Question 16 says a boat moves at a constant velocity v through still water. A constant drag force F acts on the boat. What is the power used by the boat to move through the water? So first of all, simply we can imagine this one is boat and there is a drag force on the boat, so we can draw this arrow to represent drag force, that is equal to F, and this has velocity V, and this is moving at constant velocity. It means the thrust force is also equal to F. Now we can find out the power used by the boat. That has to be the product of force and velocity. So the answer for this question should be B. Question 17 says the diagram shows four forces acting on a circular disc. Each force has magnitude F. Two of the forces act vertically and other two forces act horizontally. All four forces act in the same plane as the disc. No other forces act on the disc. The disc has diameter small d, which statement is correct. Now if you look at this given disc, we have four forces, and if you look at forces along horizontal direction, we can see we have one force along horizontal, we have another force. They have the same magnitude, so the F net along horizontal, this one is equal to 0. And now if you look at forces along vertical, means along vertical direction, we can also say this one along horizontal, this is along vertical. We have two forces, one is up, one is down. They have the same magnitude, so F net is also equal to 0. So we can simply say in this case F net on the disk, this is equal to 0, because no net force along horizontal, no net force along vertical, it means net force is equal to 0. Now we need to look at the moment. Due to these two forces, first of all we have these two horizontal forces. So here we have two horizontal forces, and this distance between them is equal to t, and these two forces, they form a couple because they have the same magnitude of force, they are acting in opposite direction, so they form a couple. And moment due to these two forces, this moment will be clockwise, so this moment will be clockwise. So we can say along horizontal we have clockwise moment, so we can say clockwise moment, that will be equal to one force times the distance between two forces. So clockwise moment we have Ft along horizontal. Now we can look at forces along vertical, and the distance between these two forces, the separation between these two forces, this is also t, and the moment due to this force will be clockwise, and due to this one also will be clockwise. So we can say along vertical moment is also clockwise, and that is equal to Ft. So we can say net moment, in this case net moment is equal to 2Ft, because Fd plus Ft, and this moment is clockwise, this is clockwise, this is also clockwise. As there is a net moment, it means this is not in equilibrium. So we can conclude from here, not in equilibrium. Not in equilibrium means this disk is not in equilibrium, not in static equilibrium. Now if you look at given option, first of all in equilibrium, this is incorrect. Not in equilibrium because the resultant force is 4F, this one is incorrect, resultant force is 0. So this option is incorrect, this option is also incorrect. The disk is in equilibrium, incorrect. The disk is not in equilibrium, this part is correct, because the resultant torque is 2Ft, this is 2Ft. So the answer for this question should be D, and this is also incorrect. So this is a way you can answer. This question is about equilibrium, so we need to look at forces. Net force means the forces in all directions, net force should be 0, and moment about any point also has to be equal to 0. Question 18 says a ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S and T, the ball has kinetic energy E sub Q, E sub R, E sub S and E sub T respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. Which difference in kinetic energies is the smallest? So for this question, if we take this line as our reference line, so here we are taking reference line, and at this point EP means the GPE, this is equal to 0. mean potential energy, gravitational potential energy at this point is equal to 0. So it means that at any point above this one, ET, this will be equal to EP, means the potential energy plus EK. And total kinetic energy is equal to the total energy, means at this point total energy is equal to kinetic energy, because potential energy at this point is equal to 0. And as the ball is moving up, ball is gaining GPE and ball is losing KE. As this total energy is constant, means E total, this is constant. So if this energy is increasing, it means this energy is decreasing. So it also means that the change in GPE, this one has to be equal to change in KE. So if the change in GPE is smallest, it means change in KE also is the smallest. So simply we need to look at change in GPE. This height is 1.5 and this height is 1.6. So what is the difference between these two heights? Delta H is equal to 0.1 meter. And this difference in height is the smallest. So it means that the difference in kinetic energy at this point and difference in kinetic energy at this point, that is the smallest. So the answer for this question has to be EQ, ES. So we have EQ and this is E sub S. So the answer should be A. So this is how you can answer this one. Simply you need to understand total energy at any point is constant. So if kinetic energy, let's say, decrease by 1 joule, potential energy will increase by 1 joule, and vice versa is also true. So using this understanding, we can answer the question. So the answer for this question should be A. Question 19 says the battery of a small tablet computer is initially uncharged. It is connected to a constant 10 watts power supply for 2 hours to charge the battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? So first of all, we can calculate input energy. This is from the power supply. We have 10 watts power multiplied by time 2 hours. 1 hour has 60 minutes and 60 seconds. So the energy we will get in joules. And efficiency of charging process is given, that is 80%. So we can calculate E out, and E out is the energy stored in the battery, So this is equal to E out, energy stored in the battery. Efficiency simply is equal to E out, useful output energy. So E out useful divided by E in, and this is the useful energy. So we can also say this one is useful, means the energy stored in the battery. We need to find out E out. So this is E out. Simply this will be equal to the efficiency times E in. So here we have E in. Efficiency is 80%, means 0.80 of input energy. 10 times 2 times 60 times 60. So if we solve this one, we will get about 5.8 times 10 to 4 joules. So this is energy stored in the battery. Pretty straightforward question. Just simply you need to understand efficiency. If we write down, this is percentage efficiency, this one has to be equal to E useful over E in multiplied by 100%. So if we are talking about percentage efficiency, so this is very important one, useful energy output. So we can find the answer. So the answer for this one should be C. Question 20 says an initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is capital E. One fragment has mass m and the other one has mass 2m. What is the speed of the fragment of mass m immediately after the explosion? This question is about conservation of momentum. So first of all, simply we can try to sketch. Imagine that this one is the firework Initially this one is at rest, so its initial momentum is equal to 0. Then after explosion, it's split into two fragments. Let's say one has mass m and the other one has mass 2m, and these two, they move in opposite directions, so they move in opposite directions. Let's say momentum of this one is p, momentum of this one also has to be p, because the final momentum also has to be equal to 0. So these two, they have the same momentum. Because this is an isolated system, there is no net external force acting on the system, so momentum of the system should remain constant. So from here we can conclude they have the same momentum. This is the main concept. Now it is given to us that the total kinetic energy given to the fragments is equal to E. So we can say the kinetic energy of one ek1 plus kinetic energy of the second fragment is equal to capital E. And kinetic energy we can write down in this form, ek, this is equal to p squared divided by 2m. If you don't understand this formula is very important to answer tricky question. We can derive this formula quickly as well. P is equal to mv. From here we can say v is equal to p divided by m. Then we can write down kinetic energy. This is equal to 1/2 mv square. So we can say this is 1/2. Here we have m. So we have v square. So this is p square divided by m square. So this m we can cancel with this m. So we will get in this case p square divided by 2m. So this is how we can derive. Now we will be using this one here. And so we have p square divided by 2. What is the mass of fragment 1? That is m. And the second one, p square divided by 2. What is the mass of the second one? That is 2m. And this has to be equal to E. So we can say this one, let's say this energy, this is equal to ek1. So how about this one now? So we can say this one is ek1. So how about this? So here we have p square divided by 4m. So it means this one is ek1 by 2. So this is equal to E. I hope this makes sense. Means we have written p square divided by, we have 2 and here we have 2m, and this one, this is equal to ek1. So we can say this is ek1 divided by 2. So this is how we got this ek1 by 2. So from here we can say now this side, if we add these two together, we will get 2 plus 1, so we will get 3 by 2 ek1. This is equal to E. So from here we can say ek1, this will be equal to 2E divided by 3. So this is the kinetic energy of fragment 1. We need to find the speed. So we can say 1/2 mv square, means for fragment 1, this is equal to 2E divided by 3. We need value of v. So we can write down these two. If we multiply with 2 here, we have to multiply here as well, so we will get this is 4E, and if we divide by mass on both sides, we will get mass here. So this is the mass. So this is v square, but we need value of v. So simply we need to take the root of this one. So finally we can say v has to be equal to 4e divided by 3m, so the root of this one. So this is our final answer. So this is final answer. Now if you look at given options, 4e by 3m, so this one is the answer. I have done this question in detail, but if you have clear understanding, simply you can start with this one here. Writing formulae, find value of ek1, and then use the formula for kinetic energy 1/2 mv square. You will be able to find the value of v. I hope this question makes sense to you. And if this question is clear to you, and if these videos are helping you to improve your understanding of physics, please like and subscribe, and also leave some comments in comment sections. And also if you have any questions, leave your questions in comments. And if you're looking for more resources, join Patreon. See you next video.